pop up. That could be a problem with OneNote. Is that what this is called? I think so. Okay, here we go. All right, we're in. Let's see if this works. We already had a fail. Yeah, this is good though. That wasn't even moving the other hour, so there was something wrong in the setup here. So trying our second video of the day of this set of notes. Period 5 doesn't know the difference, but just telling them a story. Okay, so hopefully this works. First things first, you got to have these memorized up here, right? Right. You don't have those on your note sheet. As I was thinking about how to, develop the notes for you, and present them to you. Oh, well, I probably should remind them of those, right? Um, and there are going to be times where we do have to make a choice. We have to make a choice. You'll see this as we're coming up when we have 3 different ones. We're going to have to make a choice. Which one is best for the scenario that I'm involved in? And then talking about this one, this was my favorite of all the 3, right? Because as the least complicated denominator, which makes my life a little bit easier than most times. But sometimes we do want to use some of the other forms. It depends how the question is. Then I looked at this and I said to myself, all right, warm up. And I go, I know we've done these before. Oh, okay, I see what they're trying to do. They're trying to make a connection that we can now do these in 2 different ways. But let's remind you of the first way. So what I have to do is go to my calendar, which I did. I did some adjustments for the calendar. Did anyone get that message? Did anyone get messages when I put something on Google Classroom? No? Okay, I put this in your Google Classroom, the 4th quarter calendar. Okay, so now it's going to start. Isn't that better? So we don't have to keep scrolling down. That's why I do this too. But what I did is I put a clip of those notes from like 3 weeks ago. These, and actually I don't want that because I want you to remember this, but I'm not going to do any writing. I'm just going to take what the old teachers did. Remember, well, I mean old, like Karen Cooper's old. The other teachers. Don't get me in trouble. All right. I don't want to be in the principal's office the rest of the year. Okay, do you remember sine 3x? Sine 3x is 3 sine curves from 0 to 2 pi, right? So what did that do to the amount of answers that we could get? It tripled them. So what we had to do for questions like this, just recall, sine of theta equals a half. Well, that's just pi over 6 and 5 pi over 6. But when it's 3 theta, then what I have to do is triple the amount of answers by adding 2 pi and then 1/3ing all of those answers. And lo and behold, 29 pi over 18 is smaller than 36 pi over 18, which is smaller than what? I'm pointing to it right now. 2 pi. So that proves that those are the answers that should happen. That's all I need to show you. That establishes an idea. So what do we do for this? We said to ourselves, okay, oh, by the way, sine of a 30 is what? What's sine of a 30? 1/2. So is that a 30? Yes or no? No, it's the other one, which is what? 60. So wrong. When I do my analysis for the angle measure, the cosine's gone. So cosine of who is negative 1/2? The 60s in quadrants. Where's cosine negative? Like, I don't want to assume you know anything. It's great. People forget everything. 2 and 3. So it's a 60 and 2. 3 pi over 3 jump backwards. 3 pi over 3 jump forwards. But then also, I always like writing this for my students. I have to add 2 pi to these answers because the amount of answers is doubled. So therefore, 6 pi, that's 8 pi over 3. And then that's 6 pi plus 4 pi, 10 pi over 3. And then I'm going to change my colors because what I have to do is take half of those answers. So when I inverse cosine negative a half, I free the 2 theta, but then I have to solve for theta, which means I have to take half of both sides. Divide by 2, but you have those, it's better, it's smarter. And then lo and behold, you end up with every over 3 on accident. Remember that? Yes, it's fabulous. Okay, and then we should have faith in that. This one, what does 1/2 sine of theta over 2 do? That halves the amount of answers I could possibly. That's actually a little iffy. It really depends. So what's great about this is all I have to do is theta over 2 equals inverse sine 1. By the way, 1 over 1. Y is 1, R is 1. I always reduce myself to that. That means X has to be 0. Where do you get 0, comma 1? Where's that located? Pi over 2. Now here's why I don't add 2 pi to this, which would be 4 pi over 2, 5 pi over 2. Because the next thing I have to do is multiply by 2. And that becomes pi, and that's the answer. If I would add 4 pi over 2, that's 5 pi over 2 times 2, that would give me 5 pi as an answer, which it is an answer, but it's bigger than, just say it so your brain's activated. It's bigger than 2 pi. The only reason we had to do that in the previous one, the directions that I have to follow, that I'm forced to follow. Okay, so if I would have added 2 pi and then multiply both sides by 2, just gives me an answer outside of the parameters. All right, then the last one, this one's a little strange. I do have to add sine 2 theta. 1 sine 2 theta plus 3 sine 2 theta is 4 sine 2 thetas. The ability to just treat this as a variable. And then sine 2 theta is equal to 2 over 4, which is a half. What's sine of a 30, everyone? What's sine of a 30? 1/2. So these are the 30s. They're the 30s in 1 and 2. But wait, there's more. Because of the 2, I have to double the amount of answers by adding 2 pi to these original ones and then halving. And then half of 17 pi over 6 is 17 pi over 12, which is smaller than 24 pi over 12. All right, now just keep the colors. Don't feel like switching. 13 pi over 12 is a smidgen past pi. And then 17 pi over 12 is short of 24 pi over 12 by a lot. So it fits in the parameters of the directions. Okay? All right. Now look at what we have. We have a cut and a paste of the same exact questions. But consider the equations involving these identities. Can you solve these using the above identities and doing a replacement? We'll see if we can or cannot. This first one, how many options do I have? How many options? 3. Why do I have those options? Oh, that's a big yawn right there. Am I boring you, perhaps? Now, why would I not choose the first one? That has two variables. Yeah, then yawning back there, Doa. You know, yawning's contagious. Now it's going all over the room. Okay? It's got 2 variables. So I don't care which one you use. I think in last hour I did the 2 cosine squared minus 1. Just for giggles, I'll do 1 minus 2 sine squared of theta. Because that's a replacement that's legal for that. It does work. Last hour I did 2 cosine squared minus 1. The cosine squared minus sine squared is unsolvable. 2 variables. Two different trig functions with one number. Not doable. Okay, subtract. No, you know what I'm going to do? I'm going to multiply by 2. I'm just going to get rid of that. And then subtract 2 and divide by negative 4. Hopefully you can stick with me. When I subtract 2, that's negative 3, but it's negative 3 over negative 4, which is 3/4. Right? Now here's the beauty of this. When you square roots, the beauty of this is, what do you put in front of your fraction? Plus or minus. Why is that beautiful? It takes care of all of our quadrants. All 4. We're sign positive. Why don't you go ahead and answer that like in 3 seconds? We're sign positive. 3, 2, 1, go. 1 and 2. But we're sign negative. 3 and 4. So you got them all. You got 1, 2, 3, and 4. What's sine of a 30? That's not a half. So therefore, this is how you play the game. I still have people that can't play that game. 60. So it's all the 60s. That's it. It's over. So it's all the 60s. Isn't that what we got up in the answer over there, right? When we did this the other way, right? Yes, it is. Okay, so this is a legal and kosher way of doing this. Circle it up. Okay, this one's weird and it causes me a little bit of anxiety. Ooh, that's a word we use a lot. All right. Sine of theta over 2. I only have one rule for it. There's no multiple. It's plus minus. That gives me a little anxiety. Square root. That gives me anxiety because when I'm going to have to square. Whatever I square, that can cause false answers. You got to watch this. All right, now sine does not like cosine. Ooh, minus, you negative cosine. And then that equals 1. That's just my little device to remember the formula. And I'm going to have to square. Okay, I have to. It's the only way I could free that from there. So now I'm a little nervous. Anytime I square, I'm going to keep this separate from this. I'm going to go back to green, not that anyone cares. But now I have a siren going off in my head that since I squared both sides, I may get some false answers. This is true. It's going to happen here later in the notes. I'm going to multiply by 2. 2. So if I multiply by 2, 2 times, I actually lost myself there, so I had to write that to collect my thoughts. Subtract 1 and then divide by a negative. Don't we get a negative 1 there? And then isn't theta, there's only one spot where that happens. That's at pi, right? Is that the same answer we got from up here? It is. And I was just playing around with that 5 pi in case you overcooked that question. Now I can plug it in real quick. It's easy. What's pi over 2? What's sine of pi over 2? Just read that answer. What's sine of pi over 2? I plugged it in and it worked. So I know I'm good. Okay, so we're all fine. The last one, this one caused me to pause the other hour. Remember when we reduced this down to this, right? Isn't that what we got it down to when we did our, yeah. And then can I use an identity for this and will it be helpful for me to solve? That's the identity for sine 2 theta. And what do you think the answer to that is? Is that helpful or extremely unhelpful? It's extremely unhelpful because how many variables do I have? 2. So this is a no. This doesn't really, it wouldn't be a way to approach this one. I'd have to approach it the old way, right? And that's why we're making this. Good job by the other two making these notes here, because you do have choices now. Now that we've given you the identities, what these are, we do, and sometimes we have to use our new way, which is use our substitutions. But if we have to use the old way, we'll use the old way. All right, now we look at this. Hopefully the video's still popping around here. It looks like we're okay. We'll see. Are those the same variable? Yes or no? 3, 2, 1, go. No, this is as different as this if this said sine of x equals sine of y. These could not be combined in any way, shape, or form. These arguments are different. That is the word we should be using, argument. So how can I get this to be similar? I can do a replacement, and now I have equal arguments. Okay, and that's why I need to do this. Do you miss my cold room? I see some people putting their hoodie on. Is my room the coldest? Or no, it's not? How many people think my room is the coldest? Raise your hand. Okay, you do, you do. What's your coldest room? Which one? Compass? Okay. All right, now, should I do this like 60% of my A B'ers? What do you think the answer is before you even I even do it? So should I do this? Yes or no? No. No, 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 no. You actually, I'll show you which answers you lose when you do that. You actually lose 2 answers. You do. Here's what you should do. Subtract the sign. And then this is causing me a lot of problems mentally. All right? Mentally, I cannot handle how many A B'ers can't factor this. What kind of factoring is this? Greatest common factor. And I cannot believe what some of them write. Good foilers say it. Liars! Because you're a liar if you don't check that sine times 2 cosine. Does that give me this when I throw it in? Yes or no? And then the sine x times 1 give me minus sine x there. Yes or no? It's amazing what I get in this line right here. The nonsensical mathematical gibberish that is written here after this is done, because students, good foilers, say it. Well, it's actually good distributors, good factors. Don't do it. And haven't done it till August, since August, and still don't know how to factor. And we're almost in April. And that's a big problem. All right, anyway, thanks for listening. You're my psychiatrists. Oh, and it's not excusable. Whoever say, why do you yell at the students? Because they're doing things they shouldn't be doing. Naughty. Should be arrested mathematically. Thrown in math jail. All right. So then I use the zero product property. Hey, remember when I did that division thing? You would have lost all of these answers if you would have done that. Where sine of x equals 0. 0 over 0 over 0 over 1. Y and r. With x being either plus or minus 1. Where is that located at? 0 and pi. And then where's sine of a 30 is a half, so these are the 60s. Sick of asking that question as well. And then where's cosine positive? 1 and 4. And I'm lazy about putting them in like actual order. I just solve one, solve the other, and slap them together. Okay, is there anything I had to check on that? No. I didn't square both sides or anything, so I'm pretty confident here. This one is really strange. How many variables do you see? I can't even say the word. 2. But I do know this. This is looking close to one of these. Trying to get your brain to be, what does it look like it's close to? But there's something missing. The very top one, right? Top left. What do I have to introduce to both sides? A 2. Okay, so it's all about looking at your identities and then tricking yourself. And then this now is sine 2x. It's a reversal. I'm doing the reverse of what I did in the previous examples. So now what I have done is got this down to one variable, but it's a double angle. Oh, then I could just do what I did 3 weeks ago. Question. That's why we have to bring up 3 weeks ago. All right, so sine of who is 1/2? Boy, we're sick of that question. I did a quiz. I shouldn't talk. But we did do a quizzes today. And still I got people that can't answer that question. I just got sine of pi over 6, and people are still picking root 3 over 2. I can't. I don't even know what to do with it. That's why I say you guys are you're on Pluto. We'll wait for you to come back whenever you're ready. 12 pi over 6 added to that. Then we already have the set answers. And then 12 pi over 6, 17 pi over 6, right? Didn't we? Did we already have this in the notes at some other shape? This is why the repetitiveness. This is why it's inexcusable you don't know your unit circle. What are you doing? What are you doing with your homework? What are you doing in order to get this memorized? I got the homework grades. Your guys are fine. A B'ers? Oh, it's a train wreck. I would say it's like 50-50. How many people turn in their homework in there? Why is homework average still like a 70 though? What happens with all the people that don't do their homework? What do they get? Lockport, what do they get? 45. You know how many people have an under 50% homework average? It's mind-blowing. Mind-blowing. Under 50. So you're barely like, you're sucking, speaking of all the honors, you're sucking all the oxygen in this room and not using any of it for your brain. Do anything. Do nothing, expect nothing. Thanks for listening again. I needed this. Okay, obviously, we don't have the same variables and we don't have the same arguments. So we got a big problem here. But I do know, I want to look at this one on the left, because I do know that I have this option. Plus minus, sine can't stand cosine, you negative cosine negative over 2. And then that's not theta though, that's x. Caught that because I did want this. Okay, so I do have, now I have them in terms of cosine x. So one little simple change, I can get it. Now, here's where I got a problem. You got to be careful. When I square both sides, there can be an issue now. There can be a false, an answer that works after the squaring, but not before. And you got to worry about the before. You got to worry about satisfying this equation, not this one. This one is slightly different, and I'll tell you why. What happens, happens. And it's always the reason. This is always the reason what's going to happen here. Where these answers work and why we got this false positive. Speaking ahead of myself. So let me just keep going mathematically. Then you know what I'm going to do? I'm going to get this side to be 0. Add cosine of x. And subtract 1. So I'm going to get the left side to be 0. And then good FOILers, good factors. And then I have a positive. So what should be here? Positive 1 or negative 1? Because what I'm thinking about is this. What should be on that underneath that line? Plus 1 or minus 1? Plus 1 or minus 1 where that line is. Plus. Why? Because that's positive 2 cosine, and then this would be negative 1 cosine. Good FOILer, say it? This is good FOIL because I did check my FOIL while I was factoring. Your factoring is always so small. They don't really get real tough with the factoring on the AP exam, right? That's a 2 cosine squared instead of those tough ones we had in the beginning of the year. Okay, and then what's x equal? Well, here we already had these. Sine of a 30 is a half, so this is a 60. It's the game. It's the game. And then where is this positive as well? And then where do you get negative 1 over 1? That's x over r. Again, for those that are behind and don't know how to get these, that means y has to be 0 for the Pythagorean theorem. Negative 1 comma 0 is at pi. You know what? And that's the first one I'm going to check. And then I'll tell you the why this happened. I plug in pi. First of all, what's cosine of pi, which we just had to analyze? What's cosine of pi? Negative 1. But then I plug it in here. What's pi over 2? What's the sine of pi over 2? 1. So does 1 equal negative 1? Yes or no? So this gets me 1 equals negative 1. But what happens when you square both sides? What's 1 squared and what's negative 1 squared? 1. This is true. This is false. This is what happens when you square both sides. You get a false true answer because it works after the squaring, not before. This isn't always. And always, why you should always check when you square both sides in your process of solving. You better check your answers or else. All right. What's 5 pi over 3 over 2? What's 5 pi over 3 over 2? 5 pi over 6. What's sine of a 30, which is over 6? 1/2. And then what's sine of 5 pi over 6 in quadrant 2? 1/2. What's cosine of 5 pi over 3? 1/2. And then it's the same thing for pi over 3. That becomes pi over 6. When I put it over 2, sine of pi over 6 is the same as cosine of pi over 3. So those do work. You better check them all. All right? All right, I'll speed this up. All right, remember when we had 3 of these? Just going to get to it. Which one am I going to pick? Cosine squared minus sine squared? 2 cosine squared minus 1? Or 1 minus 2 sine squared? Which one? You got to pick the right one or else you're a fool. You create your own problems. You don't use common sense. Let's just put it that way. Common sense must be the way we live now. So add 2 sine squared, subtract 1, nice. That gets me this. And then I don't really have to check my answers if I don't have time. You do get a lot of them sometimes. I think this one does give us a lot. Maybe not. Maybe I'm thinking of another one. And then I'm not going to bore you anymore. This is BC. You should be good at, everyone should be good at factoring. AB and BC. Something's going on with AB. I don't know what it is. Can't pinpoint it. So you guys know about GCF. We've already covered it. You know about zero product property. We don't. You're severely and totally behind 3 years ago. The 3 years ago concept. Or maybe your freshman year. And then where do you get 0 over 1? I believe we had these answers. I get that at 0 and pi. And I get this one at pi over 6 and 5 pi over 6. Just want to make sure I'm not going too fast. I think that's pretty much it. Everyone good? Went over that fast. Just stalling to wait for anyone to catch up. Catch up. What should I have for dinner today? I always hate having to make dinners. I want something simple. I got the 2 kids at home. What do they want? Sammy never likes what I make. It's a vicious circle. Are we good? Here's what's weird about this one. This is definitely El Strangio. Then the last one, I'm going to go through the same process I went through with 4th hour. I kind of panicked a little bit because I ran into a circle of, I ran into a lot of problems, let's just say. But here's what I recognize on this. I need these to be the same. And I recognize something about sine 4x. That's sine 2 times 2x. Where I'm tricking myself that I'm thinking about the double angle identity. But the argument is 2x for the formula. Can anyone see what I'm saying there? So therefore, why I would do that is all I need is to get these to be the same variable, same argument. And therefore, this does happen. The rule is this. And then I guess I'll highlight where this is the rule to sine cosine. And then of who? The argument, that angle, and that's in those positions. I don't know if that helped, the highlighting. Just trying to have you see the double angle formula at work here. Okay, and I guess I could put these in parentheses to make it look better. And then, okay, these are the same, and not only the same, they're the grade anyone, greatest common factor. I'm serious. You should see what I get out of this. Not having a 1 here, because this times 1 is that, plus, and then this goes away, 2 cosine 2x equals 0. When I throw this back in here, I do get that. Just the inability to see that. I can't help those people anymore. It's been too long. Too long to get this figured out. And then let's get the zero product property done on this. So it's subtract 1, divide by 2. Then this is the one that's going to have a lot of answers. Okay, so I'm going to start way over here. 2x equals, we already had this. We're sine 0 over 1. It's where x can be plus or minus 1. It's 0 and pi, but the amount of answers is doubled. So I have to add 2 pi to these answers. So that's why these come about. You got to figure that out. And then 2x also equals, let's change colors and put these in green and try to make this go a little faster here. Sine of a 30 is a half, so this is a 60. That's how the game is played. And it's a 60 in quadrants. Which quadrants is cosine negative? 3, 2, 1, go. 2 and 3. So it's a 60 and 2. A 60 and 3. But then I have to add 2 pi to these. So that's 8 pi over 3. And then that's 4 pi and 6 pi, 10 pi over 3. And then I got to take half. Let's go blue now. Half of all of these, because that's what 2x equals. Half of all of them. Oh, I think we had this before. Do you need me to write all those? I'm not going to. Half of 0 is 0, 0, pi over 2, pi, 3 pi over 2, and then all the over 3s. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Right? And all those answers are between 0 and 2 pi. That's why it works. I did not square both sides to solve. Can you imagine having to check all those answers? Nobody has the time for that. You got to be mathematically sound on that. Okay, I'll leave that there for a second, and then I'll tell you my story about fourth hour and how I panicked a little bit, but then got out of it. So what I did, and I like doing that, and I tell you guys, unfortunately I cheat for you because I already go through the notes with fourth hour. I kind of scan the notes, but I go, you know what? No, if I struggle, I want to struggle in front of you guys because part of this can be a struggle. Part of this is I can try something and it's wrong. And I paused fourth hour to start with because I knew there was a problem. Sine 2x and cosine 2x. First of all, these are not the same variable. This is unsolvable as it stands. Can't combine these in any way, shape, or form. I know sine 2 theta is 2 sine x. I should have done that. Let's try that. Sorry. You have to rewrite it. That's 2 sine x cosine x. Okay, so that's fine. Then I got stuck with cosine 2x because how many different ways can I do that? How many different ways can I do that? 3. I'm not going to pick the cosine squared minus sine squared one because what do I do with that? Like I have some cosines, some sines. I have two variables all over the place. So then the first one I thought possibly was this one, but then the problem is, you get this equals 0. The 1. I'm always gonna have that 1 floating around there. Like I thought maybe I could do a GCF kind of factoring, but that wouldn't even work. Even if that 1 wasn't there, I'd have a 2 sine squared. I'd have a 2 root 3 sine x. I pull out a sine, I still have cosines and sines all over the place. I got into a panic. I'm like, nothing would work that would get one variable that I could factor or GCFing or whatever. I'm like stuck. And I'm like, I could do this. Root 3 sine 2x equals cosine 2x. Let's see if anyone can see what I would do next. Give you like 10 seconds to think, and then raise your hand if you think what we would do next. Nope. He was going to raise his hand, but he scratched his ear. 5, 4, 3. I'm going to divide both sides by something. 2. Were you going to raise your hand, or then you went to? I thought you were going to pick your nose. I've been picking my nose all day, but it's been on the outside because I got my nose is peeling so I can see the white skin. Just so you know. I don't want to be accused of, yes. Oh. I think the way we have this is we should be dividing both sides by cosine. I think it would have been fine if you did sine. Then you would have, yeah, you would have been fine. You're right. You would have just dealt with cotan then, right? Okay, you're totally correct. Okay, and then what's sine 2x over cosine 2x? I kind of just said it. What does that become? Tan 2x. And then this becomes, sorry, I had the 2 in my head there. And then this is not 0, it's 1. Okay, that's another thing that crushes me. The right side. Cosine 2x, same thing over itself as 1. And then this becomes tan 2x is equal to 1 over root 3. And then this is easy. What I've been doing with the A-Bers today was just trying to go back to old school ticks. And then old school, hey, if you're still struggling with the unit circle, then put 30 degrees 1, 60 degree side is root 3, 90 degree side is 2. I can't memorize that. Well, that's the problem. We can't memorize anything. Memorize something, right? And that's why this is a 30, right? Because y always represents the reference angle. Where else is tangent positive? Quadrant 1 and what? 1 and 3. So it's the 30 and 1, the 30 and 3, and then it's doubled. So I have to add 2 pi to these. I just like seeing it for you guys so you understand where I'm getting the 13 pi over 6. 12 pi plus 1 pi. 12 pi plus 7 pi. Put it off to the side so I just grab it when I need it. So I can visualize these answers. Then I'm going to be lazy again because we've gone long enough. Have all of these angles. Okay, and then that'll be it. Right? Is that it? Okay, leave this up here for a second. So, happy to struggle a little bit with fourth hour and verbalize like the whole thought process of why nothing worked on a replacement. So I needed some different thought process. Okay, starting to lose my voice. I'm out of practice.